And our next panel is Spectrum and Infrastructure in the 5G World, Upending Current Paradigms. And I'm pleased to have 4 Spectrum experts with us today, including Reza Arefi of Intel, not Dean Brenner, but John Kuzin of Qualcomm, Prakash Marut of Nokia, and Anders Svensson of Ericsson. Each will give a brief presentation, and then we'll have a panel discussion. So, Reza, take it away.
All right, thank you, Peter. Good afternoon, everyone. Hope the lunch was good. Maybe the lunch was too good. People are still eating. All right, so I decided I talk about not specific bands or which spectrum is in the pipeline, which one is coming, which one has better chances and all that, but rather talk about, in general, about some of the challenges and at the same time opportunities that we see with 5G spectrum-related topics. And hopefully these will be answered, and within all of these will be answered in terms of challenges within the next few years as the world prepares for 5G spectrum. So I picked a few statements that you hear about these days, and let's talk about the challenges and opportunities associated with these statements. First one is that 5G is expected to be deployed around year 2020. So as you know, and we were before lunch, we were talking about, the panel was talking about how deployment of 4G is not consistent around the world. In some countries, we're still dealing with 3G, 4G LTE is just ramping up. So what would happen within a few years if 5G is going to come? What will happen to those markets where they're still ramping up on 4G? What would the operators face in those situations? Would they skip 4G and directly go to 5G, or will they just stay behind more than what they are now, and then that worsens the digital divide issue? So that's a challenge, and how to deal with this the issue of disparity between different parts of the world in terms of deployment of new technologies. The other challenge is that even the preparation process takes time, and 2020 is only a few short years away. There are a lot of regulatory steps that need to be completed for instance, in the ITU, within regulatory bodies in different countries, in terms of the assignment of the spectrum, or if they need to do any repurposing and all that. And all that takes time. The ITU needs to do the studies. Administrations all need to be convinced. And everyone has to be nice and happy about it for it to happen. So all that takes time. The opportunities we see associated with the year 2020, however, is that now it might be only a few years away, but we have a deadline. We have a stake in the ground, 2020 as the goal. And having a goal always helps. Having a deadline always helps us reaching there. And ITU has said that 2020 is the deadline for finalizing the specifications and all the spectrum-related matters for 5G. And we have a goal that we all work towards. That's I look at it at least as an opportunity to get things done because of that stake in the ground. And even though it's only 5 years away, it does provide opportunity for front runners, and every new technology needs front runners. And and that provides for the opportunity to break new ground, and then the followers will follow, of course, right? And this is another opportunity related to the year 2020, even though it's not too far ahead in the future, right? The next statement that we hear about these days is that 5G is expected to utilize millimeter wave bands. The challenge is that cellular industries have never used these bands for cellular kind of operation. There are a lot of things that need to be addressed, for anywhere from the technology, the equipment, the propagation, the cell planning, all of that is going to be all new grounds to break. The other challenge is design of low-cost user devices. Again, yes, there are the technology using millimeter wave bands has been around for quite a while, but not for low-cost commercial devices. So that's another challenge, how to bring the cost down to the level that you can put into a user device that you can sell at a reasonable cost. Another factor is propagation impairments that significantly limit the range of these systems in millimeter wave, right? So these are all challenges. Now let's look at some of the opportunities that come with the use of millimeter wave bands. With some of these higher bands, we have the potential for very large chunks of spectrum that we don't see it in lower bands, because lower bands are more crowded. Higher bands are less crowded. Yes, there are allocations and all that, but that doesn't mean they're actually being used with operational systems. A lot of times, it's just the allocations in the allocation tables of regulators, but without any actual systems being deployed. And they offer really multiple gigahertz per band in cases. And that provides the opportunity for big, wide channels. Several hundred megahertz, for instance, of carrier bandwidth. You look at the largest portion of the 28 gigahertz band in the US, it's 850 megahertz, and that could easily provide for several hundred megahertz per carrier. We said design of cost-effective user devices is a challenge, but we also had the opportunity of 60 gigahertz. Even though it's an unlicensed, mostly indoor kind of technology based on WiGig or 802.11ad, and which is now IEEE is working on the next generation of that, 11AY, with even larger channel bandwidths. Up to more than 7 gigahertz of channel bandwidth. But it has given the industry the opportunity to work through problems, solving problems related to RF implementation, antenna implementation, and things like that, and putting them into form factors such as tablets. You can go on Amazon and buy a tablet with WiGig today, and it works. So the industry has done that, and that has provided and is providing us with some insight into how to tackle problems related to building equipment for some of these other higher bands. Yes, we have higher propagation losses and very high penetration losses through walls and even glass and all that. But higher propagation losses for the signal, the intended signal, also means that the interference will go through the same. So interference will also not propagate too far, and that will help with coexistence with some of the other systems. Both intra-system and inter-system interference could be managed is expected to be managed in an easier way than it is for lower frequencies where interference travels large distances. The other statement about 5G is that 5G is expected to operate in low, mid, and high spectrum bands. We hear that because of the variance in the applications, each application requiring a different type of spectrum optimally. So the expectation is that 5G will be deployed in below 1 gigahertz, below 6 gigahertz, and above 6 gigahertz, up to millimeter wave maybe. So what the challenges, some of the challenges related to that is, again, implementation of in user devices. Are we going to see all of these different types of radios in a single device, or in multiple devices, or would you see it a 5G device having a 600 megahertz radio as well as a 28 gigahertz radio? And what are the challenges with implementing that in terms of antenna? They certainly cannot use the same antennas, right? So there's challenge for implementation, all these different bands to support different applications in user devices. Another challenge is that with this, of course, it means that, with this statement, it means that the number of bands that 5G is going to support is going to go much beyond what 4G is dealing with, and we have a problem with 4G related to that. Finding, in order to support global roaming and movement of devices, if you have to support all of these bands in a device, or most of them in a device, that is definitely a challenge. Now, some opportunities come with this statement also, and that is that by supporting from very low to very high frequencies, you get the opportunity to support the variety of applications that are envisioned for 5G, and some of them are well articulated in the ITU recommendation on the frameworks for IMT 2020 or 5G. Anywhere from enhanced mobile broadband to massive machine-to-machine to mission-critical and ultra-reliable systems, and they all have different requirements in terms of spectrum as well as other technical requirements. And in order to, if we get to actually do this, to cover all of these bands, whether with a single radio or multiple radios, that's not the real issue here. But if we could cover all of these things in the future system of 5G, that helps us to enable this vision of the connected society where everything that computes is also connected, and that is a real opportunity if we could actually get there. And also going into higher bands, as we said, it opens the door to ultra-wide channels and bandwidth, with a lot of things can be done, and we can see that, for instance, with WiGig. What is possible now with WiGig was not even was quite unheard of. Like 10 years ago, no one would even think about it. That having a 2 gigahertz, 2.16 actually to be precise, gigahertz of bandwidth would enable you to have speeds up to like 4 gigabit per second. You can transfer a full movie in a second or two, right? So that is a reality now because of the bandwidth, and so that's the opportunity that comes with. That's all I had. Thank you.
Perfect. All right. Thank you very much, Reza. Next presentation is John Kuzin of Qualcomm, and let's see how. And then just use the left and right arrows. Great. All right. Thanks.
Good afternoon, everybody. It's a pleasure to talk in Washington about a subject that we can all agree on, which is the need for more spectrum. And you know, the importance of spectrum for today's 4G and tomorrow's 5G networks and the need to make more available for mobile broadband use, that's what we're all working on here on the panel. I know most of you are as well. And Prakash from Nokia is going to do a great job talking about particular spectrum bands. Reza just laid out a lot of the challenges and some of the opportunities to deployment. And I'm going to focus a little bit more on the infrastructure issue and the underlying technologies. But before I get into that, I just want to underscore one of the points that Reza made, which is when you're asked what type of spectrum does 5G need, low band, mid band, or high band, the answer to that question is yes. You know, you need it all. And one of the things that's critically important is low band spectrum will continue to be absolutely essential, and higher band spectrum will be used to supplement that. And it's very important for the reasons Reza laid out. The high band spectrum has wide bandwidth, more direct propagation, and because of that you can really take advantage of it and provide high throughput. You can address more easily, perhaps, RF exposure issues and things of that nature. So, so what is 5G? This slide just kind of lays out that 5G is going to be a completely new kind of network that serves a much bigger role in our lives than previous generations. Basically a connectivity fabric for everything. But how is 5G going to achieve this vision, and what technology breakthroughs are going to be needed in order to scale to the extreme variation of use cases envisioned for 5G? And it's no secret that 5G is going to build on the transformation that began with 4G LTE. 5G networks are not going to fall out of the sky like a baby from a stork's mouth. They're going to be built upon all of the advances that were made for 4G LTE and defined and enhanced via advanced technologies such as carrier aggregation, LTE Direct for direct-to-direct connectivity, and LTE Broadcast, to name a few. So 5G is going to have to support a huge variability of communications needs across devices, from very high data rate, always on operation, to very low data rate, low duty cycle needs. It needs to adaptively scale up or down depending on performance needs. And it's going to be designed to support three main service examples. One is support for a massive number of things. What things? Anything. You name it. If it has power, it could be connected to the network. Number two, support for mission-critical services. And number three, enhanced and improved mobile broadband. So all of these needs require technology improvements, and some necessitate extreme improvements in several dimensions. Also, to be abundantly clear, the extreme variation is driven by two of the three use cases that I laid out. And the first one is this. To connect a massive number of things, we need to scale down in cost, data rates, and power to provide highly efficient and extremely lean solutions. Most of the use cases on this slide can be served by simple devices with low data rates and low cost. At the same time, a growing number of connected things need high performance, high reliability, low latency, and the ability to scale up in complexity, mission-critical services to control critical infrastructure, robots, drones, the medical procedures remotely, and the like, are going to require ultra reliable, highly robust, and extremely low latency connectivity at levels previously not required for most other services. So at the same time that we move to support massive IoT growth and mission-critical applications, there remains this growing need to provide ultra-high-speed connectivity with sub 100 milliseconds latency for today's typical mobile users. This is basically the next generation of the technology that's in our smartphones today for video, voice, and data applications. So the 5G unified air interface has to address these extreme variations, and the way it's going to do it is to basically multiplex a wide variety of 5G services with various levels of data rate, mobility, latency, and reliability. 5G is going to use optimized OFDM-based waveforms that can scale from low spectrum to millimeter wave, from macro deployments to local hotspots, and will support licensed, unlicensed, and shared license spectrum from the beginning. New 5G multi-connectivity technologies will need to seamlessly support simultaneous connections across different access nodes with opportunistic carrier aggregation for enhanced performance and reliability. This includes aggregating millimeter waves from a small cell with lower spectrum bands from a base station. New 5G technologies are also going to expand multi-connectivity to include device-to-device connectivity, manage multi-hop communications, and relays to extend network coverage. So 5G, as I've said, is going to leverage the existing 4G, 3G, unlicensed investments in multiple fronts. It's going to simultaneously support connectivity across all these technologies. So by way of an example, an operator may deploy 5G in spectrum under 3 gigahertz. Take, for example, the 600 megahertz band that's expected to be actually available for mobile use around the year 2020. That is likely going to be the first 5G band. And as these millimeter waves become online, an operator could integrate them in areas of high capacity needs. And later on, as 2G, 3G, and 4G are refarmed, those could turn into 5G connections as well. So I just want to reiterate where I basically began. So 5G is going to be new and improved, highly reliable interface, but 5G networks are not going to appear out of nowhere. They're going to use as a foundation all of the technology advances that were developed for 4G, many of which are on this slide. Thanks a lot. I look forward to your questions.
Thank you, John.
I'll do it.
Very good. Just use left arrow, right arrow.
Can you use this one too?
Yes. Maybe not. Oh, yes. Does work. Okay, next presentation is by Prakash Marut of Nokia.
Hi, good afternoon, everyone. I'm going to share the views of Nokia on 5G spectrum. Some of the spectrum bands that we see in the pipeline worldwide and also in the US to allow the deployment of 5G over the next 3 to 10 years, even beyond that. Before I start, there was this second panel this morning that was discussing, spectrum. So I wanted to wait before I made some comments. I don't necessarily agree with everything that was said this morning, especially about, U.S. leadership, etc. 700 megahertz band was quoted as an example where it was a mess, and U.S. had a band that's basically being used by just U.S. and Canada, and the rest of the world is using a different band. But sometimes that's what happens when you lead, correct? I mean, Germany is just auctioned the 700 megahertz this summer. We cannot wait for 7 years. France will auction the 700 megahertz later this year. So that's 7 years later than the US. So it wasn't perfect, but that didn't prevent AT&T and Verizon from, having devices that support 700 megahertz. I mean, they can command the market. They can get, Apple, Samsung to include those devices, and, Ericsson and Nokia's infrastructure vendors, we are very grateful for that. But FCC actually took the action back then to make it happen. The other comment was also about some of the announcement around the Winter Olympics in Korea, I think in 2018, and then some other events. But no one mentioned that just in September, Verizon made an announcement about doing 5G in 2017 timeframe. And actually at least some initial deployment. And I can tell you, working for a global company, you know, selling equipment worldwide, this has now become the benchmark for all of the industry. And China actually is trying to see how they can beat Verizon and do 5G next year. So we'll see. But again, you know, we should not like beat ourselves too much. I think FCC is doing a great job. If you compare with CEPT, you compare with other regulators, FCC, I think is trying their best. It's not. I think Reza asked a good question about the value of some of the spectrum that the fixed satellite services are using, or you know, other services are using, and can these be repurposed for mobile broadband sooner rather than later? I'm going to address some of his bands later. But anyway, I just wanted to start with some of his comments. I guess the last comment I had was, you know, the European Commission pouring billions of dollars in 5G research. Again, Nokia is a European company, Ericsson, same thing. We are, you know, using that money to do R&D research. I mean, R&D in 5G. But when it comes to actual deployment, it could well happen in the US. You know, the money we use doesn't mean that you're going to deploy with Vodafone first. I mean, we saw that with LTE. Similar things happened with the European Commission. We were involved in many other projects, but Verizon was among the first to deploy. It wasn't Europe. So anyway, I just wanted to have these comments, and we can discuss later during the panel discussion. I think Reza and other people this morning already mentioned, and even John did a good describe some of the use cases that we had for 5G and why we need all the spectrum bands below 3 gigahertz, between, you know, above 3 gigahertz, in the millimeter wave range, etc. A lot of the focus has been on the millimeter wave range, and I think, you know, it's good that we try to push back the spectrum frontier and make it happen. At the same time, we just wanted to caution that there are spectrum opportunities in the lower bands, and for different use cases, they can be very useful. So if you look at bands above 6 gigahertz, from 6 to 100 gigahertz, for example, this is what ITU actually discussing for 5G. There are multiple criteria that you can use in order to assess which bands make more sense for 5G. Reza already mentioned some of the criteria, like having enough contiguous bandwidth, you know, so that you can deploy, like, you know, large channel bandwidth, etc. One criterion I think that's very important is to look for bands in the radio regulations across the world, including in ITU, which already have a mobile service allocation. That would be one less battle to fight. And then you can go and try to get an IMT designation for those mobile bands. So what I did, and it wasn't fun, so I look at the regulations for Europe, China, Japan, Korea, and US from 6 to 100 gigahertz. Okay, and look for bands that already have a mobile location in those bands from 6 to 100 gigahertz. That's 94 gigahertz of spectrum. So the light blue, I'm not sure if it shows that light blue here, but basically the light blue on this side are bands below 30 gigahertz, so below the millimeter wave range, that have a mobile allocation in these different countries. And the dark blue represent the bands that have a primary mobile allocation above 30 gigahertz in the millimeter wave range. So, you know, a couple of, I guess, lessons from these. First, there's a lot of bands that could become potential candidate bands. So, and then the other lesson is that if you look at the centimeter wave range below 30 gigahertz, the chunks of the spectrum that have a mobile allocation tend to be smaller. Around 28 gigahertz, you do have some bigger chunks, and Reza already mentioned 28 gigahertz. And 28 gigahertz also the potential for harmonization worldwide, in many regions. The other band that has some good potential below 30 gigahertz is around 15. It's not available in US with a mobile allocation, but it's available in Korea, Japan, China, and Europe with a mobile allocation. So 15 gigahertz, 28 gigahertz, below 30 gigahertz, could potentially be harmonized at least in 2-3 regions worldwide. When you look at frequencies above 30 gigahertz, a couple of things. First, the chunks become much bigger. So the amount of contiguous spectrum you have in the millimeter range are bigger. So if you have 4 free operators, and each one have 1 gigahertz of spectrum, that's a dream for them. So you can actually fit 4 or 5 operators with 1-2 gigahertz of spectrum for each one of them. So when we look at spectrum above 30 gigahertz, some of the bands stand out, especially around 64 to 76 gigahertz. Reza already mentioned the Y-gig band. The Y-gig band goes approximately from like 57 to 64. So just above that, you have another chunk of 12 gigahertz of spectrum, 64 to 76. And we can leverage the technology that we're developing for Y-gig, etc., to make that happen. So below 30 gig, I would say 15, 28, and above 30 gig, this range around 64 to 76 has some good potential for harmonization and allowing us to reach the gigabit per second target rates that we've discussed throughout the whole session. But again, going back to what I was saying earlier, looking at spectrum above 6 GHz is definitely useful, but there's opportunities for spectrum below 6 GHz also. So just based on what I showed, at least Nokia's position is that at this point in time, it's better for ITU to study the ranges before we narrow down specific range, specific bands. So for example, I mentioned 66 to 76 or 64 to 76. So we can study that range and maybe at the end of the study pick only 5 gigahertz. That make more sense. In the US, the FCC has already started the notice of inquiry. We are expecting the NPRM to start sometime in November or October of this year. So our recommendation to the FCC is to keep all of the bands we have in the notice of inquiry as part of the NPRM so that we can continue the discussions and then at the end of the process narrow down the specific bands. So this is this shows the different proposals by regional bodies. So CITEL is America, basically represent the Americas region, so North America, South and Latin America, CPG, Europe, APG, Asia Pac, RCC, Russia, and then ASMG, I think the Arab countries. Again, if you look at the different bands here, you have enough bands above 30 gigahertz. You see there's plenty of bands here, candidate bands that these countries or regions want ITU to study. But when you look below 30 gig, you have some bands around 28 gig, but below 20 gig, there's just one band around 10 gigahertz. So, I think it's good to start with millimeter wave, but I think going forward, we really need to push the administrations to go below that. And one of the reasons is that these bands are used by fixed satellite services and other incumbents, and I think administrations are not ready to take on the battle with these incumbents. But our goal is to continue to push them to do that because there's enough spectrum even below 30 gig that we can use for 5G. So so we'll need to continue to push for that. Okay, so moving one step further, if you look at the situation in the US. We prefer exclusive spectrum access. You clear the band, you auction it. But when you look at the pipeline in terms of auctions happening, next year is going to be 600 megahertz, and John already mentioned how 600 could be used in the context of 5G. But beyond that, we had the auction of 700 megahertz in 2008, and then AWS-3 just early 2015. That was 7 years in between the two auctions. And next year we'll have 600. I'm not sure when FCC will auction any new spectrum. We'll see. So that's why I think that we also need to look into shared spectrum and also unlicensed spectrum. And I think that also complies with what we've heard before. There's a lot of spectrum at 5 gigahertz band. There's already 580 megahertz. FCC is looking at adding an additional 195. So that would be a contiguous 775 megahertz of spectrum. Shared spectrum. So there's discussion right now. Actually, the FCC has already issued its report and order on 3.5. It is the first one. A second one is expected by end of this year. On shared spectrum around 3.5 gigahertz. So that's 150 megahertz of contiguous spectrum. It comes with some challenges. It's owned by the US Department of Defense, like for radar applications, and also by the FSS, fixed satellite services. But that's 150 megahertz of spectrum. I mean, we don't get 150 megahertz of spectrum, that often in the US. But if you look above that range, there's another 500 megahertz that's owned by the same FSS incumbent. So that's an additional 500 from 3700 to 4200. And then below that 3.5, there's an additional 450 megahertz that's owned by the DoD for similar applications as radar. So if we extend the current 3.5 gigahertz framework to include those two additional ranges, that would open 1.1 gigahertz of spectrum below 6 gigahertz. We can look at millimeter wave, but I think shorter term, in the next 2, 3, 4 years, I think those bands might also have some good, might represent some good opportunities for the deployment of 5G. And I think it doesn't necessarily need to be a new waveform, a new version. It could be an evolved version of LTE, for example. And in 5 gigahertz, it could be an evolved version of Wi-Fi. So there's opportunity below 6 gigahertz. It's not perfect. It's not like clear in spectrum, but at the same time, it's not clear to me when we're going to see, hundreds of megahertz of spectrum cleared below, below 6 gigahertz per operator. And then obviously at the FCC's millimeter wave bands, again, our position is that FCC during this NPRM notice proposed rulemaking phase should consider all of the bands they had in their notice of inquiry. It's too early for them to narrow down specific bands. And then continue to push the FCC to look at bands between 6 and 24 gig. The two bands I mentioned around 3.5, which didn't just come up with those bands. There was the FCC Technological Advisory Council last year that had a working group on advanced sharing, and we have the vendors, the operators involved there. And we came up with a list of bands here that represent several gigahertz of spectrum that could be made available for mobile broadband below 6 gigahertz, and especially around 3.5. As I said, the existing framework is 35, 50, 100, but then you have bands around it. And when you lump them with each other, you can open up gigahertz of spectrum for 5G, and then hit the gigabit per second data rate that we've been talking for 5G throughout the day. Again, that will require a lot of work, I guess, with the FCC, the incumbents, but we already have started to look at sharing in 3.5, and that framework could be extended to other bands here. So I guess there might be need for us to change the way we look at spectrum, especially below 6 gig in the short term. Sharing, we need to prove it works, obviously. If it works, and I think there's work already in like Wireless Innovation Forum where standards are being specified, and other places, even in Europe, in ETSI, looking at sharing. Maybe that framework could be extended to open some additional bandwidth for mobile broadband. So in summary, exclusive spectrum access is preferred. At the same time, how realistic will that be below 6 gigahertz, in terms of providing megahertz or hundreds of megahertz of bandwidth per operator. The 600 megahertz auction next year, if we get 120 megahertz of spectrum, once you put out you remove a duplex distance, you remove a guard bands, you may end up with maybe 2 times 45 megahertz of spectrum, 45 megahertz uplink, 45 megahertz downlink, and then if you have 3 operators bidding, or 4, you'll get 10 megahertz uplink, 10 megahertz downlink. So you can use it for some 5G applications, but not for everything. So some of the bands around 3.5 could be used for other 5G applications. Obviously, harmonize spectrum harmonization, maximize harmonization, at the same time realizing that if you want to lead, sometimes you need to take risks. So, and then, obviously look at bands beyond the millimeter wave, look at bands below 30 gigahertz, not just above 30 gigahertz. That's all I had, Peter, so thanks.
Thank you very much. There will be a quiz on all those bands.
Yeah, you can take a look at the slides afterwards.
All right, and the final presentation is by Anders Svensson of Ericsson. Thank you, Anders.
Thank you. So I selected to focus on a specific area when it comes to coordination between spectrum when we are deploying it for 5G. Jan have already showed quite significant what 5G is all about, and also Prakash have looked into the different details of the spectrum here. So I will focus more on how they can interact together and what's the benefits are of that. So, but first, let's look at why do we need it. Yeah, if you're looking for spectrum, it's mainly driven, there is a lot of the new devices with IoT and so on, they will not really require much spectrum from a capacity point of view, but they will require the lower band spectrum in order to get the penetration. However, what we can see this is data for North America, what we expect the capacity increases will be for the next 5 years. And I will show later on that if you have this type of growth with the current network, it will not really be able to sustain the capacity need. So what we see is that there will be a growth both in the number of smartphones that will be deployed, but also the usage per user will significantly increase in order because of the demand, especially in video, where video will be more and more used on the mobile device, not only at home with Wi-Fi, but also in general public where you're walking around. So if you look at one important aspect in 5G is that you actually can coordinate between the legacy networks as well as the lower spectrum when you transfer it over to the next generation waveform, the 5G waveform. We will have a backward compatible LTE 5G version, which could also use for coordination and control signaling of the higher band 5G access. As we can see, it will be deployed in both low bands and as well as high bands, and I will talk a little bit about the different characteristics of the higher bands, how they are important to consider now when we are allocating the more spectrum. But first, look a little bit about what is the benefit of actually being able to tightly couple the lower band and the higher band. So here is an example of simulations that we have done, where you actually show that you have a lower band, in this case with LTE, but it could be a 5G network as well, as you have deployed with a certain capacity and certain need. This could be an example for where you are today. And then if you look at it, if you increase the capacity needs as we predict for the next 5 years, and look on the upper right from your perspective, you can see that it's all red. And that's because the capacity is not able to cope. The system is not able to cope with the capacity needs that have been. You can also see that the average speed for the end user goes down from 66 megabits per second to half a megabit per second. If you then look at deploying in a higher band, which in this case is the 5G 15 gigahertz band, we add that on and deploy that with a 100 megahertz carrier, it will still not reach up to the capacity need that we had, or the capacity that we actually have today, or the end user, I should say the end user behavior or end user experience that we have today, because of the great capacity and because of the less penetration of the higher band. However, if we start combining and they work together with carrier aggregation and tightly couple them, then you can see that because of that there is a dynamically movement between the capacity between the two frequencies, you can see that the end user experience now go from 18.4 megabits per second all the way up to 98. And in the three last, there is the same amount of capacity that this is supported, but it's three different versions of spectrum that is used. So the benefit of having coordination and tightly couple the upper band with the lower band is very important and will be very important for 5G. Hence, there will be a very big need for having low band as well as high band when you deploy your 5G networks. So if you look at it from a perspective, which spectrum is most beneficial and for different type of deployment, and here I focus on the spectrum that is above 6 gigahertz. The lower band, like Prakash was talking about, is still very important, and we need to allocate more capacity and spectrum in the lower band as well. But from a physical perspective, the characteristics are more different in the bands that is above 6 gigahertz. So that's why I'm focusing on this here. And what we see is that on the bands that are between 6 to 20 gigahertz, it's suitable, especially together with, coupled with the lower bands, to actually be deploying in a similar fashion that we have today, and we'll have systems that are very much beneficial of that, where you can have an outdoor-in approach, even if the penetration is lower. And you can leverage the deployment that you have today with macro network and so on. With higher bands, like above 20 and 30 and even above, there will be a need for a completely new architecture in that sense that you will need to have small cells in much larger scale than what you have today. And that will be naturally, like we discussed before, very complex from a deployment perspective and so on. And there will be need for other technologies when integration with the backhaul and et cetera and so on. But the value and importance of also allocating spectrum in the 6 to 20 gigahertz in order to continue with the current deployment models as well is very important. So I think that is important that we include that, like Prakash said, as part of the evaluations that is done by FCC, also US. So as a summary, the key components here when we are evaluating spectrum now for the higher bands is that we need to take into consideration the coverage consideration. That is mainly focused on the lower bands, or mid bands I should say, where you had different propagation characteristics. We need to address the different RF power levels in order to support that type of deployment. What is the deployment scenarios in metro area, outdoor area, and hotspots, as well as quality of service. On the higher band, which is more focusing on getting the density and high speed, where we can actually allocate much more bandwidth for the individual channels, then it's the high user data rate, the number of users that can be supported in a very small area, like arenas and so on. And that would be part of that deployment. So in essence, we need to consider all aspects at the same time when we are allocating the spectrum. So that's it.
Okay, Andrew, thank you very much.
I don't know if you want to keep that.
Yeah, sponsored by Ericsson.
No.
All right.
I didn't know how to get it.
We'll have to increase your dues if we do that. Oops, that's even, I think we had a generic slide. All right, I give up. Uh-oh. How about that? I accidentally found the slide I was looking for. All right, I'm not going to mess around with that any further. Prakash, can you explain, the one thing we didn't really go into was the WRC conferences and the role that will play, and maybe the timing of that relative to the FCC and PRM, just so people sort of understand the spectrum roadmap for the next 5 years?
So I think, in terms of how the FCC and PRM will, how do you say that, take place compared to WRC, I think FCC will probably come up with a list of bands.
And we're expecting that this month or next month?
It will, yeah, the NPRM will start, I think we have it at the open meeting on October 22nd. I think it will be voted, and then the NPRM should be released either end of October or November. It will have a list of bands in there, we'll see. The NOI already have a list of bands. We hope they'll keep the same list, or we'll see if they've narrowed it down. And then I think it's going to be taking maybe 2 years. So by 2018, they'll have their list of bands that will become then the candidates for World Radio Conference of 2019. So that's how I see this playing out. So FCC will have a list of bands that will issue.
And then the objective of WRC 19?
Would be to try to harmonize bands around the world. I mean, we already have a list of candidates that I've showed. Some of them like around 28 gigahertz, around I think 31 gigahertz, and even around 70 gigahertz appear on all of the regional proposals. So I think these bands have a good chance of being adopted as global bands. At the same time, as I said, we've seen FCC before, like 700 megahertz again. They don't necessarily need bands to be accepted by everyone. You know, they think that, you know, US by itself is a sufficiently big market to sustain a ban. Korea has the same thing, and Japan. If you look at the Korean bands and Japanese band, they all tend also to be very unique. They have the same issue that we have. Sometimes it's very unique. But at least this time, I think FCC is trying to harmonize. So.
And a general question for the panelists. Which band will see first 5G deployment globally, and which one will see first 5G deployment in the US? Just speculation.
I'll speculate first. I think the first 5G band in the US very likely could be the 600 megahertz band. And the other bands, probably 28 and 39 gigahertz, will also be, you know, smaller deployments because they're microwave bands, would be my guess for the first ones. And then obviously, you know, the points that everyone's raised is WiGig at 60 gigahertz. If that interface is upgraded and it's a 5G interface, you might see stuff at, you know, 57 to 64, 64 to 71 as well.
Yeah, similar. I mean, slightly different view. I think with C3.5 being open. I mean, again, define 5G correct. Not necessarily a new waveform or a new interface, but just based on LTE. You know, if 600 megahertz auction happens next year, it could take a while to clear and then to deploy. 3.5 gigahertz is already there. So again, you know, define 5G, and then the other question is. You know, are you talking about pre-commercial and how much deployment we'll see, etc.? But I think 3.5 is also a good band. So.
Okay. Anders, you want to add to that, or?
Yeah, I think I agree to some extent with the previous speakers here. That 28 and 39 definitely is candidates for the millimeter waves and so on. When it comes to the 600, there have been a discussion if that would be the LTE first or NX or the 5G first. And I don't know, that will probably be driven by the ecosystems and when it will actually be released by the broadcasters and so on. So it's difficult to speculate exactly what will be available when they will deploy it, depending on who is buying it.
Okay. Anything?
Well, the only problem with speculation is that it's difficult, right?
Yes.
Well, if it was
otherwise
easy,
it's all
we
fun,
wouldn't be
right?
here.
Yeah, the rest of it is fun. Now, I just point to the FCC chairman's blog from last month. Chairman Wheeler, he pointed out the intention of the FCC to release the NPRM before WRC 15, and we welcome that quite a lot. He also mentioned the 600 megahertz as a candidate band for 5G. That was also important in the context of having spectrum in the entire range. We also note that, yes, maybe 28 and 39 are considered low-hanging fruits when we look at the variety of the bands that were presented in the NOI.
Thanks. We started the panel 5 minutes late, so I'm going to go 5 minutes late here on this side. Any questions from the audience? Larry in the back, and then Emil.
Thank you. This is a fascinating discussion of which I kind of got about 40%, maybe, and that's pretty good.
That's still a lot of spectrum.
Yeah. So the title of your panel is Upending Current Paradigms, and if I heard this right, I just don't want to be overly simplistic, but I also do want to be overly simplistic. Is one of the paradigms we just upended the idea that there's such a thing as beachfront spectrum when we talk about 5G, the way we did for LTE?
All right. Anybody? Any ultra desirable spectrum compared to any other? I mean, I've heard over and over again it's a combination of low band plus high band, but
As I said when I spoke, I think the spectrum below 3 gigahertz will be essential for 5G deployments. And then spectrum beyond that will supplement that. So I mean, in locations where there's very high demand, the millimeter wave stuff is going to be essential. But you know, in places that are less populated, it remains to be seen whether there's actually going to be extensive 5G deployments. I think the initial deployments will likely be in large metropolitan areas, big cities, where there's large numbers of users in close proximity.
Yeah, and add to that also, the low band will be very essential, like I tried to show in my slides as well, in order to get the reliability of the system when you use millimeter wave, because getting the ubiquitous coverage, you also have the control signaling going in the lower band, as well as then supplement or complement with a higher band for the capacity, will be very important. So the low band is very important.
Yeah, and it will depend on the use cases. Different bands would be very important for different use cases.
And one point that Reza mentioned in passing, which is very important, is because of the antenna needs, you're not going to have a device that can support 28 gigahertz and 600 megahertz, in a wristband. So, because of that, I mean, there's going to be for IoT type applications that need to be very low battery draw, very low duty cycle, when those devices transmit, you're going to want that signal to be received. Otherwise, that battery in that device is not going to last very long because it's going to attempt again to transmit. So, for that reason, the even sub 1 gigahertz spectrum is going to continue to be essential to have low-cost, reliable devices that draw very little power.
Okay. Emil, you have a question still? I think this may have to be our last question if we're going to stay on schedule.
Thank you, Peter. Emil Sterniolo from InStep. I was very interested in Anders' study about the bandwidth and how it was basically grouped together with the spectrum. One thing I had a question was that bandwidth symmetric for both upload and download, or was that specifically in the download direction? And then how does that become applicable to, especially with things like LTE Direct, when you have two devices communicating with one another? What are sort of spectrum requirements and bandwidth capabilities in that type of technology?
So the measurement was done. It was simulated with both, but it was measured on the downlink and what the capacity. So the numbers I show were for the downlink. I don't know. I don't have the numbers for the uplink available. But when it's more critical in the uplink, naturally, because like John said, you need to reach when you are sending up, and you are power limited on the device. You have some power limitations on the network side as well, but that's more from an health that you don't get close to the base station and so on. When it comes to the D2D or the direct connect, I don't know. Can you repeat the questions? Because I didn't grasp what you were looking for.
D2D is basically, I mean, within pretty much same cell as what I'm considering, and they're not going to be able to approach the same level of bandwidth. Are they going to be doing the same sort of correlation across multiple bands in a D2D? I don't know enough about the spec. I was just wondering how that's going to be handled.
You mean if you're running several different bands at the same time? I don't know if we have tested that part. What normally happens with the D2D is that because you don't want interference with the rest of the communication, you need to allocate certain times where you use the D2D between two devices. And so there is a coordination effort that needs to be done with the network in order for them to coordinate and communicate in direct. That's how it works with LTE, and it will be, I would assume, similar for 5G.
Thank you.
All right, I think we need to take our break now. I'd like to thank the panelists for the excellent presentations and comments.